working for business development and also international business development in efficient energy, and Mr. Obaniak as head of sales and purchasing for BITU, planning and designing data centers. Ich get an own microphone too, Corona-proof microphone. Efficient Energy, we have been founded already in 2006 and we get just over 60 employees. We are close to in Feldkirchen, a little town called Feldkirchen, close to Munich. And we have developed a chiller that works with pure water, pure tap water, actually as refrigerant. So every other chiller or also air conditioner will always need a synthetic refrigerant to cool the air, and ours works with actual pure water. So that's something very groundbreaking and particular in the refrigeration industry that has not been there before, and that's why we have also a lot of patents, more than 200 patents on the technology, because we don't want it to be copied, of course. Oh, sorry, too quick. So that's you.
Okay. Yes, I'm working for BIT. BIT is a company who builds data center, and we're doing that individual and turnkey. And the data center market is a market where we use a lot of energy, and our part of our thinking to save carbon is saving energy. So we are thinking if we are using less energy, we do a big step in that. So we have in data centers 10 to 70% of the energy is used for cooling, and we are trying to help the data centers going to 10 and not using the 70%, and for that we are using for especially products of efficient energy.
Yeah, cooling takes up a lot of the power demand in a data center. That's the basic thing. And now when we come back to refrigeration industry, it's 8% of the refrigeration industrial emissions go into the global greenhouse gas emissions. So that doesn't sound a lot, 8% doesn't sound a lot, but factually it's the same amount as for the worldwide aviation. So it looks little, but there's still a lot of impact. And also 17% go into of the refrigeration industry contribute to the global energy consumption. So it does make a lot of sense to look at your cooling equipment and to see where can I reduce energy costs and where can I in return then also reduce CO2 emissions. So we have various times also talked today about the change of the climate, about global warming, also about droughts and also floods and other natural disasters. So we do have a global warming, we cannot deny it, and because of the global warming we of course have also an increased demand for cooling, because we will need more cooling, not only for air conditioning, not only that we can be at 18 or 20 degrees, but also to cool food, for the supply chain, for medication. So we need more and more cooling in every areas of our life. But more cooling means more energy, more power input, and hence more CO2 emissions that again lead to an increase of global warming. So it's really a vicious cycle, but we do have one solution how we can get out of that, and Mr. Obaniak will say a little bit more about it.
Yeah, as I said, the first important thing is to save energy for cooling. That's the first point. But the second point is, or the second question is, with what kind of refrigerant I do that. We have refrigerant, and everybody is talking about global warming potential, and the global warming potential, I think it's 2008. That's one of the refrigerant was put in place, I think the last 3 or 4 years. That's at the moment I think it's more or less it's out. It's just used for small units. The refrigerant above that, it's also out. Nobody uses that in the future. The R143A is it's old, but that at the moment from the normal refrigerants, that's state of the art. It's usable. It's okay. R32 is you see it's much better. The worst thing is it's flammable, and nobody likes to have flammable things. Oh, sorry. And nobody wants to have flammable things in the data center. So the data center guys don't like these refrigerant. So we are often using R530A. So this is the it's also state of the art at the moment. And then we have all the refrigerant above that. They are called the natural refrigerants. And the best one you can use is water. You can drink it. It's it's normal water, and you're using it as a refrigerant. And all these other things are chemicals. So water is definitely the best one you can use. Ammoniac is also good, but also flammable, and it's not healthy.
Don't drink it.
Propan is explosive as well. So you see, every refrigerant has his own thing why you don't like to use it, and the only thing what is really good is water.
It's also, we say, a dangerous refrigerant because it's the only refrigerant where sharks can swim in.
This is a table. As I said, the best way to save or reduce carbon is to save energy. And on this slide, you see the red line is what you normally use for energy, for cooling for a data center over the year. And if you see the green line, this is possible if you are using free cooling. And free cooling is cooling if you're using the outside temperature to cool your data center or your industry or whatever, as long as the outside temperature is lower than the temperature of the water you needed. So you can save a lot of money and a lot of energy if you are doing this free cooling. And especially if you're doing that with special kind of chillers, for example, the e-chiller from Efficient Energy. You have an extended version of free cooling, that's the blue line, because you don't have to switch or you don't have to decide if you are using free cooling or not, because with these kind of chillers, you have the possibility to pre-cool the water with the rest of the usable energy of the outdoor temperature, and then you have partially cool additionally by the compressor.
Yeah, and that's what we call our blue zero technology. Blue water is blue and it has zero CO2 emissions. That's why it's blue zero, the technology of using water as a refrigerant. And it's a very pioneering technology. We are the only manufacturer in the world who has a serial chiller with water as a refrigerant. So that's why we are so keen on securing our intellectual property too. And this is how this little machine looks. It has 35 and 45 kilowatts per unit, and we will also have next year a chiller with 120 kilowatts per unit, and we can add them up or stack, operate them in parallel, so that we will have up to 500 kilowatts.
Yeah, and the reason why I'm here today is the thing is not to speak about saving energy or doing new things. It's important to do it, not only to talk about it. And we installed the first beta version of the e-chiller at British Telecom. And it was a unit, yes, it looks like a laboratory machine without any kinds of design or something like that. So it was a raw machine and it was cooling. But we like to install new things, test them, and report to the production. Is it good? Is it working? Where are the problems? What happened with the machine? And so on and so forth.
Yeah, so BT has it, I think, 5-6 years in the technology.
Oh yes, I think it's
now?
6 years ago. We installed the first one for 1 year.
Munich.
In Munich. I think we had a second one 1 year later. So that was a second step of development of the units. And now we installed already 9 of these machines for British Telecom.
And they run and run.
And run. Yeah.
Yeah, we have also won a lot of prizes with our technology, and each and every one we are very proud of them. The last ones were in 2019 and 2020, the Grand Prix d'Innovation, that's from the French part of Switzerland. We're among the top 100 in the Red Herring prize for very good, innovative, middle-sized companies, and also the rubber and tire tech top from the automotive industry. Yeah, and this is why companies like BT also like our technology and trust our technology. And yeah, we would like to show you a best practice example. This is a quote from Mr. Fischer from British Telecom, and in the same time, because in this environment it's very interesting to know about strategies for zero net operation, for example. We will also talk about BT's strategy for climate protection. So you can see here in this report from the FTSE, so the Financial Times Stock Exchange Index, the report says that really only 16% of all these companies in there do actually have a strategy to become climate neutral. And all of you who are here have a strategy like that and can identify themselves with it. But I guess not everyone takes it as serious as we do as we sit here. But BT is one of the companies who take their strategy very serious.
Yes, they do. And they not even started it last year or something like that. They are doing it for 10 years. And they every year they go to all their suppliers and asking that, what are you doing to our goals? So they give the goals and asking us, what did you do that we are able to reach the goals? And we have to fill all these documents every year. And we are always pushed to get better every year by BT. So they are very, very restricted for going to these goals.
Yeah, and we will give BT a voice in this interview, video interview with Mr. Fischer. He was unfortunately not able to attend remotely, but so we have recorded this interview, and he will also talk about the BT approach to actually not only look at the BT operation, but also at the suppliers and also at their customers to implement the strategy. I hope it's
Dear Mr. Fischer, thank you for your participation in this event where we are talking about corporate strategies for climate neutral operation and decarbonization. BT is an internationally leading provider of communication solutions, as well as a business partner for digitalization. Founded in Germany in 1995, BT has since become a leading provider of global network and IT services. As a design authority manager, what is your task in this environment?
Yeah. Thank you very much, and good morning. Yes, I'm working for BT since about 20 years already, and here I'm part of the accommodation team from the beginning. We are responsible for the whole spectrum of the technical infrastructure in our data centers with regard to their planning, implementation, and operation. That includes civil works, secured power supply, structural and technical fire protection, cooling, security, and so on. Myself, I'm based in Munich and member of the design team. And yes, thank you very much for the opportunity to share my experience with regard to the use of your e-chiller technology.
Yeah, we are very happy to have you here in this presentation. So coming back to the topic of our event, how important are carbon reduction goals for BT? And is there a climate action strategy? And also, what does it include?
Yes, I think since the 1990s, the protection of the climate has increasingly been in the focus of attention. BT has set itself very ambitious goals right from the start. We aim to drastically reduce CO2 emissions, not only within its own organization. It's very important, but also in upstream to the supply chains and in its customers' business. The big goal is to bring CO2 emissions to zero by 2045. How is this to be achieved? Yes, at first for the own operation was defined that 100% of the electricity should come from renewable energy sources. As far as the market permit, of course, BT is a global company. It's very difficult to achieve this goal worldwide. But currently, the results are very good, with our 92% worldwide and 100% in Europe so far. The second target is the decarbonization of our sites. And you know it, the best way to reduce the CO2 reduction is to save energy consumption. And this should be achieved by strictly energy management to ensure efficient energy use and, in the result, reduce energy consumption. And the last one is conversion of BT vehicles fleet to electric vehicles up to 2030. The second focus is the upstream supply chains with approx 14,000 suppliers. The focus is on reducing CO2 emissions as far as possible. That should be achieved through contractual agreements like disclosure of the climate performance, inclusion of a climate-ready clause, including an agreement that energy is to be purchased 100% from renewable energies. And it is decided to go in a very closely cooperation with the suppliers to implement new innovations. And the third part is, last but not least, helping our customers to reduce their own CO2 emission by using global IT products, solutions, and services through, firstly, reducing self-operated, mostly inefficient solutions where possible, the reduction of CO2 emissions through the use of modern IT telecommunication solutions, including, for example, reduced travel activities through the use of high-quality audio, video conferences, and so on, and also to go in a very close cooperation with the customers to get new innovations.
Yeah, we have saved CO2 by doing also this web conference instead of traveling from Munich to Frankfurt. So that's good. On this present slide from the German Eco Association, we can see that we are facing a considerable increase of energy demand in European data centers. The cooling equipment presents a major source of power demand within a data center. So how does BT increase the energy efficiency of the infrastructural equipment whilst cooling environmentally friendly still?
Yes, let us first come back to the slide we see now. You see in 2010, the part of the power consumption of the cooling system was approximately half of the whole power consumption in the data center. And the target is to achieve results, a part of energy consumption from 20% or less. And let's allow us to show you an example of how the use of innovative technology in a suitable environment can be operated in an energy efficient manner, and moreover, how the environment can be protected by the use of environmentally friendly operating resources. Some years ago, BT has been looking for solutions for a high-density rack with a very compressed power density for its data center space. We talk about density from 10 kV and more per rack. In addition to energy density, very high demands were placed on the technical infrastructure in terms of operational reliability. In the end, the solution was a uniform room-in-room solution applicable at different locations. These cubes are modularly expandable, each in a power range from 40 up to 100 kV IT load. In the final stage of expansion 6, up to maximum 14 server racks per cube can be supplied, depending on the individual performance requirements. For cooling, uniformly chilled water in-row cooling units are used, which are integrated into the rack rows in the cold hot air installation. At required temperatures of 22 up to 25 degrees in the front of the rack, the very warm air emitted by the racks on the rear side is fed directly to the cooling units through a contained warm air. This enables a very efficient cooling operation with relatively high media temperatures. In the result, the required chilled water supply temperature is with 18 up to 20 degrees relatively high too. At the locations with coolant water system, this solution required, of course, an additional modularly expandable chilled water generation system. Requirements very high efficiency, safe redundancy at relatively high system temperatures.
Yeah, that sounds like a perfect application for our Blue Zero technology. And BT was also one of the very early adopters of our technology, so a true technological pioneer. Can you maybe share some of your experiences with the e-chiller along the way?
Yeah, it's a perfect frame for using the e-chiller. SBT had already been in contact, I think 3 or 2 years before the project was started, with efficient energy for several years and enabled a field test of a prototype of the e-chiller at the technical site under real conditions for about 1 year. With this experience and the very special requirements for the cube solution, it was decided to use the e-chiller at locations where a chilled water production is required. 3 e-chillers per cube feed a buffer storage tank on the chilled water consumer side. An energy management system is used to decide how many e-chillers are in parallel operation depending on the load. This ensures evenly distributed running times and a high level of operational reliability. The systems are connected to a building control system to monitor all relevant operating and performance data. In addition to the very high efficiency in operation, the e-chillers offer further advantages. By using water as a refrigerant at very low pressure conditions in the system, one is out of the strict regulations for applications with conventional refrigerants. This concerns procurement bottlenecks, costs, tests and documentation according to F-gas regulation, tests according to pressure vessel regulation. Water is climate neutral, a neutral medium with a global warming potential of 0. In addition, since the maintenance cycle of the chiller is once a year, the effort and the operational costs are very low and compared to other refrigeration systems. A maintenance contract with efficient energy is in place. BT has currently equipped 3 of the cubes described above with e-chillers. The first of them has now been in operation at the Hamburg site for over 2 years. Since then, the infrastructure has been running smoothly and with a very high level of efficiency. A big thank you to e-Efficient to efficient energy. Sorry. And many thanks for the fantastic support before, during, and after the project. Thank you very much.
Yeah, thank you for your decision to work with us, and thank you for your contribution and this very interesting insight into the BT strategy. A climate protecting and sustainable approach for clean cooling, which is an excellent best practice, I would say. And we will dive a little bit deeper in the background and the idea of clean cooling with Mr. Ubaniak from BIT, who has designed and built this cube solution for BT. Thank you, Mr. Fischer.
Thank you very much.
Okay, yeah, that was the customer voice. And yeah, we almost at the end of the presentation, but just to make something like CO2 emissions and climate saving, it's often maybe also difficult to put in numbers or to quantify, but in this case we can do that. So we have taken our installation with 3 e-chillers, and with the location in Hamburg and a chilled water temperature of 18 degrees, and we have compared it to a standard conventional refrigeration machine with exactly the same parameters, with a refrigerant, with a classic synthetic refrigerant. And like this, we have calculated that in 1 year we have a total saving of almost 12,000 kilogram of CO2 emissions, and that's during 1 year. If BT has got this technology since 5 or 6 years, then it's of course more. And to give you an idea what that actually means, if we calculate that in kilometers, it would be 85,000 kilometers of driving a middle-class car, and in 5 years that would be already almost 500,000 kilometers, which is a lot yeah, to drive. Or we might, of course, as well not to decide not to drive these kilometers and save our environment or protect our climate instead. Yeah, so water is refrigerant. It's very safe to operate, as you have heard from BT, also sustainable, and we have very low operating costs. And yeah, this is the way how we contribute to climate protection and to reduction of CO2 emissions together with our customers and our installers or our engineering offices and planners, of course, in a team. Yeah. That was us. If there is any, I think we don't have so much time for questions, but I guess one or two questions will be fine if anyone has got some.